Chalo. Let's go for our next topic, that is action angle variable. Okay. So before going to action angle variable, I will draw the phase curve of simple pendulum. Okay. So simple pendulum के लिए जो potential होता है, we will discuss in next class in general. So V theta is equal to nothing but minus mgl cos theta. So this is your simple pendulum potential. So if you are going to plot this potential, then this potential is basically periodic in nature, isn't it? There are a lot of, so this is sinusoidal in nature and periodic in nature. So potential itself is something like this, isn't it? This is your potential. Now, this is your potential. It's a very bad drawing actually. Okay. So this kind of potential is there. Okay. And now, so this is basically V theta versus theta. Now we have to plot P theta versus theta. P theta is nothing but momentum associated to theta. And that will be actually angular momentum. बाद में आप सीखेंगे कि ये angular momentum होगा, because we are rotating. So जो rotation के लिए जो momentum होता है, that momentum is nothing but what? Angular momentum. Now look at here. This value is nothing but minus mgl. This value is nothing but what? Plus mgl. Now you cannot have energy less than minus mgl. But if you have any energy between minus mgl to plus mgl, then what will happen? You have which kind of motion? Bounded motion? Yes? You have bounded motion. Suppose you can take this energy. You have bounded motion. Okay? You have bounded motion, and this is a stable equilibrium point. Similarly, you have bounded motion in this valley also. Okay? You have bounded motion. Isn't it? You have this type of bounded motion. What is meaning of that? Meaning of that, we are just talking about oscillation. Means this is my equilibrium point, stable equilibrium point. The particle will go there, again come back. Go there, again come back. Go there, again come back. Something like this. So there is restoring force is always acting on this. Isn't it? Are you able to understand this thing? Now, what will happen when my energy is greater than mgl? What will happen? When your energy is greater than mgl, that means you will be just turn the potential. You are actually in unbounded motion. Look at, if I have this much of energy, अगर मेरे पास इस तरह की energy है, suppose this much of energy, then what will happen? There is not any turning point. There is not any boundness. Everywhere my particle is free. It is just going to flow. Isn't it? Obviously. So you have something like this. यहाँ पर भी आप इसके लिए भी कर सकते हो, है ना? So you have n number of bounded motion here. ठीक है? And these are unstable equilibrium point. Now what will happen for this particular thing? Either you can rotate it 2 pi, 4 pi, 6 pi, isn't it? Is that this motion is oscillatory in nature? Is that this motion is oscillatory in nature? No. Yes or no? No, this is not oscillatory in nature. But yes, this is also one sort of period. There is some kind of period there, isn't it? Yes. हो रहा है ना? You will just find 2 pi, 4 pi, 6 pi, and you will just flow this particular thing. So how will we phase curve? You have something like this kind of phase curve, and this is your unbounded motion. And similarly, you have this kind of phase curve also. Okay. So you can rotate in clockwise direction or you can rotate in anti-clockwise direction. And what will happen for this particular MGL? If my energy is this particular MGL, then you will make a separatrix. So this will be your separatrix. Okay. So this is your separatrix. This is your separatrix. You can have this kind of separatrix. Okay. So now you can see here we have bounded motion as well as unbounded motion in a simple pendulum. Now, action angle variable will tell you all about the area under the phase curve, and that area under the phase curve is basically identified by J, and which is defined as px dx. प्लीज म्यूट करके रखो, है ना, नॉइज आ रहा है किसी का, अननेसेसरी हो अनम्यूट मत करो. So this is basically action angle variable that is identified as J, which is defined as px dx, and we are just talking about the complete period of time. When we are talking about complete period, there are some periodic function. It is not necessary that your periodic function will always oscillatory in nature. It may be oscillatory, it may not be oscillatory. So when you have a bounded phase curve, suppose you have a phase curve which is just a bounded in nature, px versus x, then this is identified as libration. इसे क्या कहते हैं? Libration. And when you have unbounded phase curve, and this can be also periodic, isn't it? We have something like this, and again you have something like this, same type of phase curve is again going to repeat. Are you getting my point? ऐसा भी तो हो सकता है. Yes?
Yes, sir.
है ना? Same kind of thing can be repeat. Just here it is going to repeat. And this is basically identified as what? Rotation. So unbounded phase curve, but it is periodic in nature. It may be periodic in nature. That same thing again going to repeat. Same thing again going to repeat. So this is basically known as what? Rotation. And when your bounded motion, when your libration is about a stable equilibrium point, that is very famously known as what? Oscillation. Are you getting my point? है ना? So what is this particular J? So what we can do, we can use this particular action angle variable to identify what will be period of any periodic motion. How we can calculate the period of any periodic motion with the calculating the value of J. Once we are able to calculate value of J, then we can easily see how we can calculate frequency or time period of the any rotational motion. Any rotational motion. Rotational motion means what? Or rotational or libration motion means any periodic motion. And this is integration over a one particular period. This is all about integration over one particular period. So let's try to go for use this particular thing to find the period or frequency, time period or frequency of any periodic motion. It may be oscillatory, it may not be oscillatory, nothing to worry about this. This is just a thing we can easily use here. And you will find that if somehow I will write this action angle variable as a function of energy, this action angle variable as a function of energy, then we can easily find what is my period or frequency of oscillation. So let's first try with the non-solution, जिसका solution हमें पता है. For example, if I am talking about harmonic oscillator, what is your harmonic oscillator? Half m omega square x square, isn't it? What will be frequency of oscillation? Omega upon 2 pi, isn't it? And what is time period? 2 pi by omega. We know this result. This is well defined result, well explained result for any harmonic oscillator. And if you are just going to do the oscillatory motion. Let's try to figure it out how we can use this action angle variable to get the time period or frequency of any periodic motion. And then we can apply this theory on any potential where there are some periodic motion can be executed. So let's try to go for this. ठीक है? So जरा हम देखते हैं, इसे कैलकुलेट करने की कोशिश करते हैं. Okay? So Now, let's try to go for harmonic oscillator. So what is your energy for the harmonic oscillator? This will be px square upon 2m plus half m omega square x square. So I can write my px is equal to root under 2m e minus half m omega square x square. So we can calculate the j value, and this j value is equal to what? Root under 2m e minus, and you can just write first formula, that will be px dx, and this value is equivalent to closed curve, and you can just go for 2m e minus half m omega square x square dx, isn't it? So this is my j value. And now if we are going to plot this particular phase curve, and we have done it a lot of times, so this is my phase curve, and we just want to calculate the area under the phase curve, isn't it? Yes or no? So what is this value? This value is nothing but what? Root under 2me. And what is this value? Root under 2e upon k. This value is also what? Minus root under 2e upon k. And this value is nothing but minus root under 2me. So somehow, if we can calculate this area and we will multiply it at 4 times, we can easily calculate this particular integration, isn't it? So can I write this whole thing is 4 times 0 to root under 2e upon k, and k is nothing but m omega square. K is nothing but m omega square. This is my value of k. So don't worry about this. Okay. So 2e upon k, and just put k is equal to m omega square, and we have 2m e minus half m omega square x square dx. So just we are putting k is equal to 2m omega square because we have taken parameter as omega. So this will be root under 2e upon m omega square, and here we have 2m e minus half m omega square x square dx. And how you will do this integration? First, you will make this integration dimensionless and try to make it clean. आप इसे क्या कर सकते हो? इस इक्वेशन को क्लीन बना सकते हो. How you can make it clean? चंचूर कैसे क्लीन करेंगे? Very good. So what you will do? You will just write j is equal to 4 times root under 2me. You can take, चंचूर अपना ऑफ करो, बहुत ही ज्यादा नॉइज आ रही है. ठीक है? Okay. And you will go from 0 to root under 2e upon m omega square, and here we have 1 minus m omega square upon 2e x square dx. Everyone is comfortable up to this? समझ में आ रहा है मैंने क्या किया है? I have just taken 2e common. Okay? And now next step, what you will do? You will take x into x is equal to some t with some coefficient, and this t should be dimensionless. Are you getting my point? ये t कैसा होना चाहिए? Dimensionless होना चाहिए. तो x का dimension क्या है? Length का dimension है ना? x is what? Dimension of length. Yes? चंचूर आप अपना ऑफ करके रखो, आपका नॉइज बहुत ज्यादा आ रहा है. अदर लोगों को बोलने दो. So x is what? Dimension of length. Yes or no? Yes. So अगर मैं 1 by length से इसे मल्टीप्लाई कर दूं तो हमारा काम हो जाएगा ना?
Yes, sir.
तो ये बताओ, ये लेंथ है या फिर 1 by length है? 2e upon m omega square root under लेंथ है या 1 by length है?
लेंथ है सर।
लेंथ है, तो इसका रेसिप्रोकल से अगर आप इसको मल्टीप्लाई कर दो तो काम हो जाएगा आपका ना? यस या नो? So I am just going to multiply it by 1 upon length. That means m omega square upon 2e into x is equal to t. Look at, मैनेज हो गया यहां पर? यस या नो? अब इस पूरे को आप क्या ले सकते हो? टी स्क्वायर ले सकते हो ना? जस्ट लुक एट दिस ट्रिक, दिस आइडिया. ये आपको बहुत जगह यूज करना होगा. डोंट वरी. आर यू पीपल कंफर्टेबल?
No sir, please explain that once again.
I am just trying to say, I just want this t is dimensionless. Are you comfortable? This
Yes, sir.
x is what? Length. Then I have to multiply it by 1 by length.
Okay.
Okay. So this is dimension of length.
Yes sir.
So I have multiplied by 1 by length. So m omega square by 2 is there. Yes?
Okay, you have done reciprocal for that.
Yes, I have done reciprocal for that. Okay? ठीक है ना? And now here you can see this whole thing I can write t square, isn't it?
Yes
Look at
sir,
very
you can.
carefully.
Yes, sir.
है ना? इस पूरे चीज को आप क्या लिख सकते हो? टी स्क्वायर लिख सकते हो. So now I can find my dx is equal to basically dt root under 2e upon m omega square. So this is dx is equal to dt root under 2e upon m omega square. Now look at beautiful part. If x is equal to 0, t is equal to 0, and if x is equal to 2e upon m omega square, t is equal to 1. Are you people comfortable?
Yes, sir.
देख लो. If x is equal to 0, t is equal to 1. Sorry. Then t is equal to also 0. Then when x is equal to 2e upon m omega square,
equal
then
to 1.
t is equal to 1. So we have make a very wonderful trick that my integration will always from 0 to 1. Are you getting my point? And all the part of energy will come outside your integration. पूरी की पूरी एनर्जी क्या हो रहा है? इंटीग्रेशन के बाहर आ जा रही है. ठीक है? एक दो क्वेश्चन प्रैक्टिस करोगे अपने आप हो जाएगा. बट इट इज वेरी इंपॉर्टेंट ट्रिक. क्वांटम मैकेनिक्स में बोर समरफील्ड थ्योरी, WKB approximation, everywhere we are going to use. In statistical mechanics, you are just going to use this all concept. Okay? चलो अब फाइनल देखते हैं. साथ साथ करते जाओगे है ना? Okay, then what will happen? I can write my J is equal to 4 times root under 2me into root under 2e upon m omega square integration 0 to 1 root under 1 minus t square dt. Yes? Now look at, this is dimensionless. This whole term is what? Dimensionless. The all variable will come outside the integration. Look at the beautiful trick of calculation, isn't it? हो रहा है ना? अगर आपको प्रोपोर्शनलिटी के टर्म में बात करना चाहे तो इस इंटीग्रेशन को करने की कोई जरूरत ही नहीं है. Because it is some constant and I can easily say my J is proportional to E. Isn't it? Now I can give you guarantee that this value is between 0 to 1. I can give you guarantee. Look at how. Just look at here. This is my curve. This is basically px versus x. This value is what? Root under 2me. हाँ या ना? What is this value? This value is what? Root under 2me. Yes या no?
Yes, sir.
Yes.
Sir.
And this value is basically 2e upon m omega square. Yes?
Yes sir.
Yes. If it would be a rectangle, what will be area under the rectangle? Leave the 4 part for other thing. Just go for one particular quadrant. So what will be area of rectangle? This height into this height? Yes?
Yes, sir.
Yes.
Yes, sir.
So height into base, isn't it? Now, so this will be the area of the rectangle. So area of this part will be what? Less than area of the rectangle, isn't it?
Yes, sir. The shaded part.
This shaded part must be less than area of the rectangle. Everyone is comfortable?
Yes, sir.
Yes.
Yes, sir.
So if it is area of the rectangle, and which should be less than this one, isn't it? This particular curvy part or the elliptical part, the area of elliptical part will be less than area of the rectangle. So I can say this value is equal to less than 1 or greater than 1 or equal to 1.
Less than 1.
That value is less than 1. So I can easily analyze that this value is equal to less than 1. But if you will go for integration, you can easily find this integration. कैसे integration करोगे? 0 to 1, 1 minus t square dt. This is what? 0 to 1, 1 minus t square dt. What will be this value? Put
1
t
by
is
2.
equal to sin theta. 1 by 2 कैसे कौन बोल रहा है? हाँ? And dt is equal to what? Cos theta d theta. And you will go from 0 to pi by 2. So you have 0 to pi by 2 cos square theta d theta. That value is nothing but pi by 4. Are people comfortable? Very simple integration. And pi by 4 is less than 1 or greater than 1?
Less than
Less than
Less
1.
than 1.
So this value is equal to what? Pi by 4. Now, this is my j. Yes, this is my j. This pi and pi will cancel out. And we have this m and m is cancel out. 2e upon omega. So this is my j. And I can write E is equal to, what is your E? E is equal to omega j by 2. And from here, if you are, is that correct? Omega j by 2 ही होगा ना?
Yes, sir.
Yes. और 2 pi भी तो होगा. 2 pi भी तो रहेगा एक. 2 pi is also there. Isn't it? 2 pi e होगा. That will be 2 pi ए. ये e हो. ये pi भी है ना? So omega j upon 2 pi. Now look at here. You got the very interesting thing. If you are going to calculate del E upon del J, what you will get? Frequency of your periodic motion. And that frequency is nothing but what? क्या हो जाएगा? Omega upon
2 pi.
2 pi.
2 pi.
So look at here. And here you can say the frequency. And if you will get the frequency, you can easily get time period. Isn't it? You can easily. So now you can see this frequency is constant because your omega is constant. Isn't it? So in the simple harmonic motion, we can easily, I have just told you that whenever you are doing simple harmonic motion, the frequency or time period is constant. But if your motion is not simple harmonic, for example, next problem I will do for that. अगर मैं next problem करता हूं, that will be not simple harmonic, then you will see that your frequency or time period will be function of energy or function of amplitude. If they are function of energy, they are also function of amplitude. What is meaning of amplitude? Maximum displacement. Maximum displacement means what? Where your momentum is going to 0, isn't it?
Yes, sir.
है ना? So let's try to go for this. अभी तक यहाँ जो पूछना है वो आप पूछ सकते हैं. So हमने क्या देखा? We have just seen if somehow I can find my energy as a action angle variable, then I can find my frequency, that is del E upon del J. It's a wonderful concept, and this is very famously known as एक्शन एंगल प्रिंसिपल के थ्रू हम देख पा रहे हैं, एंड इसी को आगे जाकर क्वांटम मैकेनिक्स में हम यूज करते हैं, और बोर ने इसी को यूज करके आगे क्वांटम मैकेनिक्स की क्वांटाइजेशन की बात की थी. ओके, एंड दिस इज अ फर्स्ट ब्रिज बिटवीन क्वांटम मैकेनिक्स एंड क्लासिकल मैकेनिक्स. ओके, not very tough but very interesting and very analytical, isn't it?
सर
बोलिए.
सर मुझे सर ये सर जीरो मतलब 0 से 1 इंटीग्रेशन लेस देन 1 है सर, ये इस वाले को लॉजिक से नहीं समझ में आया.
अरे भैया, इस
एरिया
रेक्टेंगल,
वाला
अरे सुनो, इस रेक्टेंगल का एरिया क्या होगा बताओ.
सर √2πe इंटू √2πe अपॉन m ओमेगा
ठीक है,
स्क्वायर.
हो गया. अब
यस
इसका
सर,
एरिया इससे कम होगा या ज्यादा होगा?
कम होगा सर.
कम होगा. तो कम होने के लिए इसको किससे मल्टीप्लाई करोगे? तो रेक्टेंगल का एरिया है ना,
यस सर.
तो इस रेक्टेंगल के एरिया को किससे मल्टीप्लाई करोगे? 1 से मल्टीप्लाई करोगे, 1 से कम से मल्टीप्लाई करोगे, 1 से ज्यादा से मल्टीप्लाई करोगे?
तो 1 से कम से मल्टीप्लाई करेंगे.
तो हो गया. तो
सर पर सर इसमें 4 वाला फैक्टर आ रहा है ना
अरे
सर.
भैया, वो तो चारों के लिए बात कर रहे हैं ना. गजब. अब ये रेक्टेंगल के लिए करो, ये रेक्टेंगल के लिए करो, ये रेक्टेंगल के लिए करो.
ओके सर.
थोड़ा सा दिमाग की बत्ती जला करके बैठा करो, है ना.
ओके सर.
मैं तो बात कर ही रहा हूं कि 4 को हटाओ, सिर्फ एक पार्ट देखो. 4 तो मैंने इसलिए लिया क्योंकि 4 बार मैं इंटीग्रेट नहीं करना चाहता, या फिर मैं यहां से यहां नहीं जाना चाहता. मैं एक को करके 4 से मल्टीप्लाई कर दूंगा, बिकॉज आई नो व्हाट इज माई फेज कर्व. कैसा सिमेट्रिक है, नहीं है. यस.
यस सर.
So let's go for one basic problem. Now suppose your potential is Vx is equal to kx to the power 4. ये आपके एग्जाम में भी आ चुका है ना. सपोज ये हमारा पोटेंशियल है, दिस इज माय पोटेंशियल. देन just first find J is proportional to e to the power alpha. The frequency is proportional to e to the power beta, and frequency is proportional to amplitude to the power gamma. Then find the alpha, beta and gamma. अल्फा बीटा गामा की वैल्यू क्या होगा? ठीक है, क्लियर है ये? And A is the amplitude. Now look at here. Your E is equal to what? Px square upon 2m plus k x to the power 4. Yes? Yes या no?
Yes sir.
Yes. So Px is equal to root under 2m e minus k x to the power 4. So what is my J? Integration Px dx, and that value is equal to, so now we have to just go for phase curve. So when we are just plotting my phase curve, this phase curve is also something like this. ऐसा ही तो होगा. And this value is what? Root under 2me. This value is what? ये value क्या होगा जरा बताओ. When your momentum is 0,
E by k raised to 1 by 4.
very good. E by k raised to the power 1 by 4. What is this value? Minus root under 2me. What is this value? Minus e upon k to the power 1 by 4. Isn't it? Yes. Now again, if I am going to find this value, then and multiply with 4, then everything can be done. Yes? Okay. So this is my J. Multiply with 4, 0 to, that value is e upon k to the power 1 by 4, and this value is 2m e minus kx to the power 4 dx. Now, what is first step? क्या करेंगे बताओ? 4 into रूट अंडर 2me को बाहर ले लिया. वेरी गुड. अंदर क्या रहेगा? 0 to e अपॉन k टू द पावर 1/4. यहां क्या आ गया? 1 माइनस k बाई e x टू द पावर 4 dx. t किसे पुट करेंगे? x इज इक्वल टू t. किससे मल्टीप्लाई करोगे?
K by
E by K से
e बाई k
K से
या e बाई k टू द पावर 1/4.
sorry 1/4
टू ही क्यों होगा भाई? अरे भैया 2 बाहर है. ठीक है, क्या लोगे? e बाई k टू द पावर 1/4. इजंट इट? देखो, डायमेंशन ऑफ लेंथ e बाई k, सॉरी k बाई e ना, सॉरी k बाई e लेंगे ना. So e by k is dimension of length. So we will take what? Sorry, k by e. So we will take k by e to the power 1/4. So this is length. This is 1 by length. So this is dimensionless. So now dx is equal to e by k to the power 1/4 into dt. Now x is equal to 0. T is equal to what? 0. X is equal to e by k to the power 1/4. T is equal to 1. Isn't it? सेम हो गया ना फिर से? 0 to 1. कुछ बोल ही नहीं रहे हो, हाँ या ना?
Yes, sir.
Okay, very good. So what you will get? 4 into root under 2me into e by k to the power 1/4 integration 0 to 1 minus t to the power 4 dt. And again I can claim this will be what? Less than 1. Claim कर सकते हैं ना?
ये ऐसे कर सकते
है सेम लॉजिक से. फिर से रेक्टेंगल बना करके देखो और आप इजिली क्लेम कर सकते हो. बट हमें यहाँ प्रोपोर्शनलिटी के टर्म में करना है, तो इसको इंटीग्रेट करने की कोई जरूरत ही नहीं है. देयर इज नो एनी नीड टू इंटीग्रेट दिस थिंग. सो नाउ यू कैन सी j is proportional to what? e to the power 3/4. Isn't it? हो रहा है? Yes. Now e is proportional to j to the power 4/3. So what is frequency? Frequency is what? Del e upon del j. And this is proportional to what? j to the power 1/3. ठीक है ना? अब j के जगह पर क्या पुट करोगे? e to the e के टर्म में निकालना है. So what will be happen? बताइए.
के प्लेस में हम e रेज टू 3/4 डालेंगे.
हाँ, j के जगह पर क्या पढ़ेंगे? e raised to the power 3/4. So you have frequency is proportional to e to the power 4/3 to the power 3/4 ना? That will be 3/4, 1/3. So frequency is proportional to e to the power 1/4. You can see your frequency will not constant now. If you will give higher energy, frequency of a periodic motion will be higher. Isn't it? And now you have to include here amplitude. How you will include amplitude? What is meaning of amplitude? E is equal to px square upon 2m plus kx to the power 4. What is meaning of amplitude? Anyone?
मैक्सिमम डिस्टेंस ट्रैवल.
Maximum displacement. ये तो इंग्लिश में बोल रहे हो. Just tell me in the mathematics. Hey, चंचूर तुम अपना बंद करो यार. बहुत कान दर्द कर रहा है, बंद करो इसे। ठीक है, शांत रहो, पहले अपना माइक ठीक करो, इसके बाद बात करना। ठीक है, जरा बताओ मैथमेटिकली क्या होगा एम्पलीट्यूड का मतलब?
Px is equal to 0.
है px is equal to 0. Very good. So your momentum, your kinetic energy is completely converted to potential energy, isn't it? Means for x is equal to a, px is equal to 0. This is meaning of amplitude. Okay, so from here E can be written as k a to the power 4. So now we will put it here. So frequency is proportional to a to the power 4 to the power 1 by 4. So frequency is proportional to amplitude, isn't it? So what is value of alpha? Alpha क्या आ गया? 3/4. What is value of beta? Beta की वैल्यू क्या आ गई? 1/3. What is value of gamma? 1. Clear है ये? Everyone?
बीटा की वैल्यू 1/4 है।
1/4.
Beta is equal to 1/4. Sorry. Beta is equal to 1/4. Good. Thank you. Beta is equal to 1/4. Okay? एक होमवर्क दूं, है ना?
Yes, sir.
चलो, एक तो आपके टेस्ट में जो क्वेश्चन आया था उसको आप फिर से अभी ट्राई करोगे। एक मैं होमवर्क दे रहा हूं, आप एक चीज में गलती करोगे, इसलिए मैं ये होमवर्क दे रहा हूं। ठीक है, सो Vx इज इक्वल टू infinity x is less than 0 and that value is kx, x is greater than 0. ओके, अब यहां आपको j की वैल्यू निकालनी है, टोटल वैल्यू निकालना है आपको। आर यू गेटिंग माय पॉइंट? फाइंड द वैल्यू ऑफ j, find the value of frequency, and if a is amplitude, how frequency is function of amplitude. निकल जाएगा। j एज अ फंक्शन ऑफ e निकालना है आपको, फ्रीक्वेंसी एज अ फंक्शन ऑफ e निकालना है, एंड फ्रीक्वेंसी एज अ फंक्शन ऑफ एम्पलीट्यूड निकालना है। ओके, सो दिस इज योर होमवर्क, फटाफट करके भेजो। ठीक है, देखते हैं क्या गलती की हो। सो आई थिंक दिस इज अ वेरी